sector and offshore through initiatives across the hydrogen-related value chain. Also, an associate professor of energy, manufacturing, and trade management at Lone Star College, University Park, Austin, USA, where he integrates engineering innovation, sustainability, and entrepreneurship into education. His work bridges academia and industry, emphasizing hydrogen technologies, clean energy transition, and process optimization. Through his teaching and research, he empowers students to develop practical, solutions-oriented approaches to global challenges. His leadership embodies a deep commitment to academic excellence, technological advancement, and community impact within and beyond the college. Dr. Ibrahim is an engineer with 20 years of work and research experience in higher education institutions, the research sector, the energy, oil and gas industry, and the maritime and offshore sector. He is a graduate of the Technical University Academia, Fredberg, where he specializes in energy process engineering and chemical engineering. He holds an MSc in process engineering and plant design from Brandenburg Technical University, BTU, Cottbus, Germany, as well as a BSc in chemical and polymer engineering from the University of Lagos, LASU, Nigeria. Formerly works at H2Scan Corporation and the Institute of Low Carbon Industry Processes, Cottbus, Zeta, German Aerospace Center as a researcher and project leader, where he manages international research and technological development projects. He provides decarbonization technology interventions for energy-intensive processes in key industries like petroleum refining, petrochemicals, cement, and steel production. As a subject matter expert, he offers consulting support in chemical process design, renewable energy, system technology involved in carbon capture, utilization, and storage, CCUS, hydrogen economy, and circular economy. Dr. Ibrahim is a visiting scholar and academic industry advisory board member at several universities in Africa, North America, and Europe, where he teaches, where he lectures, and co-supervises students at the postgraduate level. He has published in several international journals as well as granted patents for his research findings. He also serves as a reviewer in highly indexed international journals. Due to his extended capacities towards contributing to societal development and community service, a member of the Nigerian Society of Engineers, he is a fellow of the Nigerian Society of Chemical Engineers, NSCHE, a fellow of the Nigerian Institute of Environmental Engineers, NIEE, a member of the Society of Petroleum Engineers, SPE, and the Nigerian Gas Association, among others. He has established several startups focusing on science, technology and innovation, STI, management and transfer, and international development consultant and research commercialization firm, as well as a capacity building and upskilling hub focusing on sustainable development goals, SDGs. Despite his commitments to research, academics, and development, Dr. Ibrahim also values his family, and he is happily married and blessed with children. Please permit me to welcome our speaker for today, Engineer Dr. Ibrahim.
Yeah, thank you for having me.
Thank you very much.
Yeah.
Thank you very much. Thank you so much. We now go to the technical section proper. We are now want to welcome our guest speaker, guest lecturer, Engineer Dr. Ibrahim Kolawole Murtala. The mic is over to you, sir. You're welcome. Let's start the work, Professor. You're welcome.
Yeah. Thank you for having me, and good afternoon to everyone. I'm happy to be here to share some of the knowledge as far as hydrogen is concerned. I'm still an active member of NIE, and I think I'm also very uh, impactful in at the chemical platform, even at the NSC. So I'm happy
Welcome,
to be
sir.
here to also present here. Though I was not really cool with the delays because we had over 30 minutes. I was here 10 minutes before the time, so I had to wait. And many of my students also want to join because some of them have other classes, so I had to let them go because they'll be starting some of their class by 5:30 Nigerian time. So it will have been nice for them to also hear from some of all this because these are part of what we discuss when it comes to environmental standard as far as the energy space is concerned. And permit me to also stand on existing protocol by thanking the chairman and all the executives of Nigerian Institute of Environmental Engineers for doing this. I used to do this kind of thing with the Lagos NIE in the past in terms of organizing their technical session and bringing people on board to like share knowledge amongst ourselves. So I'm also happy to be here to also have this with the team in Abuja. Um, Aside this, I think, ladies and gentlemen, are welcome to this session. So the topic we are going to talk on is hydrogen driving global transition and environmental standard. And part of what you will see here is some of the uh, emerging trends and those things that we as a body, I mean, the Nigerian Institute of Environmental Engineers, and also all practitioners should also be looking at, especially looking at how the trends are rapidly evolving and what we need to do as a people. So I think I might put on my camera to reduce. So, and first we'll look at the global decarbonization and its imperative and why hydrogen matters. We'll also look at the application of hydrogen in different sectors and look at how decarbonization is playing key role, which hydrogen is being used for the power, for the different kind of industry, marine, aviation. We'll talk about briefly about transport, building, agriculture, and other aspects that has to do with emission. Then we'll also highlight something on environmental standard, though the aspect of the environmental standard is so wide, but I try to, uh, in fact, this is mostly like a kind of 1 to 2 semester discussion. So, but I try to kind of condense some of all this. So I will briefly look at the challenges, opportunities, and other aspects, and how the global uh, economy is looking at hydrogen and what is making hydrogen to be impactful in terms of decarbonization and what we should do as Nigerians and as NIE and also as industrial stakeholders. So let's take a look at this chart, and this provides us with the CO2 emission which has been from time memorial. So from 1900 down to the current point of this measurement by the International Energy Agency. So this is where the data stands as at now. So the one for 2025 is still, I mean, down to 2026 is still being computed. So as you can see, we still have increment and the sharp decrease here has to do with the time when we had COVID, and then we had less mobility around, but from the aviation and other sectors. So this is just to give us the understand that emission, the global emission is still in a kind of continuous process, especially from energy consumption and down to industrial processes. At the same time, when we look at the greenhouse gas emission, where it's originated from in terms of the fuel, so we know the fossil fuel ranging from coal, natural gas, oil. You can see, so they still make the huge chunk of uh, fuel that we use, and that results into many of the emissions that we have. And then you think of other fuel which has very minimal emission in terms of biofuel and others, but natural gas, oil, and coal and also maybe the peat and oil shale, they make a huge chunk. Then when we now break it down into those kind of combustion that we used to have, and I think currently too is still ongoing. So when you look at the coal, so you can see the huge emission from coal. So, and this is the total energy it supplied us. So, and when you look at oil and this emission percentage, you look at the natural gas, you look at the emission percentage. So, and others, which has, I mean, solar, you can find solar here because there is no emission, so to say, from the generation and the application of solar. So, nuclear, hydro, you will find them in the emission category. So having all this in mind, this tells us that the CO2 emission as a result of this emission will continue to have the increase in temperature. So you can see the CO2 emission as regard to the global temperature. So you can see, so the red one is CO2 emission, which I've shown you earlier. And here you have the temperature increment in terms of global warming. So having all this in mind, this also takes us to what happens in different economy of the world. So when you look at Africa, we are not a major emitter, you know, but when you look at uh, the Asia Pacific, North America, where you have USA and the likes, Asia Pacific, where you have China and the likes. So you can see a very huge chunk of the emission and down to Europe. So here, this gives you an overview. So you can see Asia. So as you can see, several years, and you can see the number of uh, emission in million metric tons. So, and you can see the Commonwealth states, independent states are here. Then that of Europe is here. Then North America. So Africa is very low. But the question now is the industrialization that has happened in North America, in Europe, in Asia Pacific, all has also resulted into several emission because all this economy depend on coal, then followed by natural gas, then down um, to other kind of fuels. So, well, you can talk about heavy residue from refining and all those things. So, at the end of the day, all these are major emitters of CO2 emission. So, and we know the energy transition could also be as a result of a lot of all those other things aside the emission, but also the decision from the United Nations Framework Convention on Climate Change, where its objective is to stabilize greenhouse gas emission in the atmosphere at a level uh, at a level uh, that will prevent dangerous anthropogenic interference with the climate system. And several conference of parties have been held from 2019 in Chile, COP25, down to, from 2009, COP15, down to 2025, and down to COP30, which was held also in 29 in Azerbaijan, and that's of the one in Berlin and all those things. So you could see that all these meetings have resulted into some decisions, and that decision has to do with how do we have a kind of balance, not only transiting, but a balance to reduce emission and what are the global action that needs to be done. And this is just to give you an overview. So this has to do with shifts to low carbon energy sources. And this energy transmission is to allow us move from dependence on fossil fuel to renewable resources such as wind, solar, hydro, and also trying to reduce emission. At the end of the day, there are a lot of policy issues that needs to be put in place, and they are already in place. Policies needs to be integrated. Some enablers needs to be put in place, structures, and also that holistic global approach must be there. At the end of the day, we look into the economy, energy, society, and the planet. So just to ensure that we're able to 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 see how we can reduce the emission. And several publications from the International Renewable Energy has also shown us a lot of all this, especially when it comes to what we need to do from local, state, national, regional, continental level. And there are several publications out there. And at the heart of it is the need to reduce energy-related CO2 emission to limit climate change. And here is a kind of simple scenario which was developed by the International Energy Agency. And here is the World Energy Outlook, where if you look at the 2020, 2018, so just have a look at this. So you can see what will happen in 2040. And the scenario is that by 2040, the increment that we have in oil will not be as much as what we used to have currently now. So similar to natural gas will be a little bit increased. You can see the line, this line. So this is the increment that you will experience in the consumption of more natural gas. Coal will decrease because now it's known that it has the huge chunk of the emission, and you can see from 3,850 to 3,750. So coal will definitely increase by 50. But other renewables will increase, so renewables will mean wind, solar, and modern bioenergy. So bioenergy conversion will take place more, as you can see the increase here. So that means a nuclear will also increase. Then solid biomass will reduce because by then we'll have had a lot of efficient bioenergy conversion processes, and I think a lot of work are being tested now. Hydro will also increase. So this scenario talks about the state policy scenario and also the sustainable development scenario. And it shows us that when we look at all these efforts, that means there will be more inclination towards the renewable energy solution. The fossil will still be there, but at the end of the day, it will also help us to reduce our emission, or maybe we talk about clean coal technology and clean emissions from cars, how we use catalysts to improve on the exhaust and all those things. So now, coming down to those uh, activities around the industrial uh, landscape. So according to PwC, they were able to come up with the approach to track companies that might meet up with the climate targets in terms of their goals. So you can say the IT and communication, electronics, manufacturing, consumer goods, automobile industry, and construction, healthcare. So as you can see, the scope 1 and 2 emission in terms of what they feel, in terms of the numbers, companies, in terms of percentage on track to meet up the targets, and for scope 1 and 2, and while for scope 3, you have this in red. So, and what do we mean by scope 1? So here is a very simple way to explain what is scope 1 emission. So which you can think about scope 1 will focus on those combustion gases that we use, as well as other refrigerants and all those kind of things. Then 2, focus on our energy generation systems like our power plants or generators and all those things. While 3, focus on a kind of production purchase material. For example, when you think about your vehicular movement, your airline, your recycling, your waste treatment, and all those things. So all these are part of what, and as you can see, CO2 is a major one, but you also have methane, you have nitrogen gases, the halogen related gases, and all those kind of sulfuric and all those kind of gases are also available there. So let's go into the sectorial decarbonization strategy, and I will briefly touch on that. So there we talk about core industrial sectors that we might be very familiar with. We know the steel industry, the cement, the chemicals, refining. So for example, in the steel industry, part of the decarbonization strategy now is instead of using coal to reduce iron ore to be able to get pure iron and also steel. Steel is a combination of iron and carbon. So in the kind of uh, coal, the kind of application for reduction process in the blast furnace, we usually use coal, but now green hydrogen is being adopted, and that's why you have projects being called green steel. Steel that are made from the production of hydrogen. Instead of using coal for reduction, you use hydrogen to reduce the iron ore, and at the end of the day, you have vapor, water vapor, so which is environmentally friendly. So another kind of industry, for example, let's talk about ammonia production. So when you have ammonia and produce urea, which is you can also have your fertilizer depending on the composition of the formula. So instead of us having dependence on natural gas to produce the ammonia, so we can also use green hydrogen from electrification, you know, and those green hydrogen could also be produced through electrolysis process, splitting of water, and all that kind of way. And that's why you have green ammonia production. And ammonia now is also being a position to be an alternative for the marine industry, where you can use this to instead of using diesel, instead of marine diesel, you use ammonia. Methanol is also coming on board. So all these are the core industry which we might look at and other aspects. So moving on, I will first start from the natural gas value chain. So we are very familiar with exploration, with the piping, liquefaction, LNG, regasification, and reuse in maybe power plants to generate electricity, or maybe we use or store and transmit for uses in industry. So at the end of the day, this uh, strategy for the gas supply value chain might change and is already changing. If you go to the port of Rotterdam, port of Hamburg, and some part of Europe, you now have something called the hydrogen blending strategy. So where you look at how the hydrogen is being blended with natural gas and supplied to industry. So that means the hydrogen and mix in certain ratio with natural gas could reduce emission at the other end where it's being used. So, and other aspects that we can also think of is how do we reduce emission in, for example, in exploration, in processing, in our combustion, you know, and at the end of the day, the key stages where decarbonization must be looked into. And at the end of the day, we need to look at how we integrate low carbon hydrogen into the decarbonization strategy. So other aspects that has to do with emission in the gas sector. So the gas value chain, we talk about flaring, we talk about venting, we talk about leaking, and some operational activities that might result into CO2 emission, or even the burning of the natural gas itself. It also has CO2 emission, some methane, I mean, non-combustible methane too within the natural gas composition, depending on different ratios of all the composition of the gas. So at the end of the day, uh, this has been well developed, where you have your natural gas uh, processing plants, or let's say the natural gas gathering system. In your gathering system, you're able to blend hydrogen into the natural gas transmission pipeline, and these are distributed to different industrial use. So that means we have the opportunity to also decarbonize our natural gas business. Though this is still something which I don't think Nigeria is still prepared for now, but at least the use of natural gas is getting more advanced, especially the CNG that has been introduced for vehicular movements, as well as other, the LNG has also been expanded and all those aspects. So, but this already at the current status, and sometimes you also have the storage of the natural gas blended with hydrogen in some kind of storage facilities. So moving from the natural gas value chain, I also want to touch on the sustainable aviation fuel. So especially from the ICAO, so from the aviation industry goals. So you can see they've also been able to come up with their net zero carbon emission by 2050. So, and there are several kind of targets that have been put in place, from different projects and different government and also different airlines and operators. So they've been able to put some strategies in place. And this is why these days you hear some of the aviation practitioners in Nigeria that say, oh, the fuel is expensive and all those kind of things, because now there's some kind of a regulation that allows you to operate when you also blend your fuel with sustainable aviation fuel, or you have some kind of biofuel mixed with it or blend with it. So, and the business case for sustainable aviation fuel is supported by various international country, industry, and individual airline goals. And as you can see here, so this is towards 2050, and it's a stepwise process. 10% SAF in the UK by 2030. So this for the UK. So, and Airline for Americas, 3 billion gallons of SAF by 2030. So these are kind of the standards that are out there. So at the end of the day, we now have sustainable aviation fuel hubs being developed worldwide. So we don't have in Africa, but Nigeria has the opportunity to do that. And I think NIE needs to be positioned to also be able to promote some of this discussion, because environmental engineers are very vital to all this discussion. So part of the challenge with aviation in terms of uh, how we are focusing on sustainable aviation fuel in terms of decarbonizing the aviation sector is that the aviation emission continues to grow. And if care is not taken, we now need to look at some of the pathways. So, for example, the hydrogen pathway is where you talk about liquid hydrogen aircraft. So some drones are being tested in Netherlands and also in some part of the world. In Japan, there's a lot of work going on in that, and sustainable aviation fuel, which we can call e-fuel, is playing a key role. Fuel cell powered aircraft are also being put in place, and at the end of the day, we want to have a kind of zero carbon emission. So, and there are some projects that have been able to demonstrate this, like power to liquid project, which I was part of. So some of all these are there for the aviation. So let's go to the International Maritime Organization, which has to do with the marine sector. They too have come up with a different approach to address climate change, especially when they came up with this uh, uh, framework where they said the decades of action to cut down greenhouse gas emission from shipping, and as you can see, from 2011 down to 2050. So, and already we are here. So, and yeah, the IMO initial greenhouse gas emission strategy objective for 40% reduction. So you can see, so now, and this is now leading us to how does the maritime organization see this? So where can we decarbonize, and how does hydrogen going to play a key role? And there you talk about different aspects of how the vessels are designed, what needs to be done in terms of power proportion, especially the system being used to propel, the full electrification that needs to be done for vessel, the integration of bow engine in terms of engine for the combustion, not only the use of marine diesel alone. So all those different elements are there. So, and then uh, when you look at all this, the major goal is to reduce emission, and also the designing of vessel now is taking new shape. So companies are already doing a lot of efforts in terms of also now using LNG itself to fuel LNG vessel. So instead of using the marine diesel, so which is a major kind of uh, milestone, and a lot of projects are being used to test this. So the solution here is liquid hydrogen fuel, or green ammonia, or green methanol, or fuel cell for vessels. It could be hovercraft, it could be cruise ship, so it could be forklifts that are being used in ports. So these are being tested. Like if you go to Port of Los Angeles, a lot of all these are being put in place. So at the end of the day, the decarbonization strategy application for sea shipping, and also offshore support vessel, and also for ports. So here we talk about how hydrogen is being used to produce ammonia, and methanol are now being used as marine fuel. So, and these are some of the emerging standards from the International Maritime Organization. So for road transport, in terms of decarbonization, we also talk about some of the strategy that have been put in place. So you talk about heavy duty trucks. So already in many parts of Europe, you have a hydrogen refining station for truck, the DHL truck that move parcel luggages from one port to the other, or one point to the other. FedEx, many of all these companies, Maersk uh, line, the shipping company, many of them are also doing all this kind of efforts. So at the end of the day, buses, trains, already you have the train in Germany, which has been in North Rhine-Westphalia, where you use, and also mining vehicles, vehicles that you use in mining fields, so which has been powered by hydrogen fuel. So, and that's why you have some possibility for electrification if you're using battery and fuel cell, some possibility for hydrogen. So, and there also some possibility also for other kind of for like biodiesel, for example. So at the end of the day, we want to cut down emission and also be able to have that kind of opportunity to contribute to sustainable development. So for buildings too, in the building sector, we also have this kind of approach. So especially for residential heating, so we don't eat back in Nigeria. So many parts of Europe experience this where they do home heating and all those kind of things, and also in North America and Asia. So at the end of the day, the purpose is to see how we can kind of partially replace natural gas, and see what can be done. And there we want to enhance resilience. So that means fuel cell is being applied. So here you have a steel plant, and here you have your public facilities, and also, and this is in Japan. And here is to give you what happens in Japan, especially during the Olympic that was held in 2020. So many of all these were tested through the Japan Fukushima Hydrogen Energy Research Field. So many of the buses that were used during this Olympic were basically powered using fuel cell system, and all the taxis were used. And this is a real live case studies and demonstration of the possibility. And this gives the Japan economy the opportunity to also diversify, So there they've been able to provide the infrastructure for the production of hydrogen, for the production of hydrogen derivative, and for the use of hydrogen derivative like methanol, ammonia for sustainable fuel and the likes. So this is just to give you an overview of what is out there. So for the agricultural space, I've made mention that we produce hydrogen and that we can produce ammonia, not only using natural gas, but a green ammonia, and we can also have a green fertilizer being produced, which can be used for the agricultural sector. And this can help us to decarbonize instead of us depending on solely on natural gas or maybe refined crude product to produce some of the chemicals that we need. So, and green ammonia can dramatically lower emission from fertilizer production. So this has been discussed. So at the end of the day, when we look at all this, why the hydrogen economy and why the emerging opportunities. So we know we used to use this as our current energy source, coal, crude oil, natural gas. They are non-renewable. So, and what do we need from them? We need to process it. We need electrification. So, and we know the energy source. But nowadays, we also want to have a kind of integration of the renewable sources, which could be the hydro, which could be the biomass, geothermal energy, solar, nuclear. I mean, a mix. And at the end of the day, we also want to gain the same thing, electrification, heating. So when we have this in mind, we can be able to look at some of the ways where hydrogen can help us to further decarbonize while we also focusing on how we can also reduce the dependence on fossil fuel. And some of the key energy transition roles that hydrogen is playing are here. So enabling large-scale renewable integration. So where we have excess electricity being produced, we can electrolyze water instead of us wasting that electricity produced from wind or solar or hydro or tidal wave from the sea, so we can further produce electricity. or even store it in batteries, or further you store it as hydrogen. So hydrogen can also serve as battery. So whenever you now need the electricity, you supply the hydrogen gas into a fuel cell and generate electricity again. So these are some of the key aspects. So we also talk about how it can help us buffer to increase resilience, and how it can also help us to decarbonize the transport sector and all buildings and serve as renewable source of energy. And why hydrogen, and part of why we need to consider all this for, you can see the emission in all this, and you can see less emission in all this. So this shows us that the CO2 emission is inevitable in this, while this is at minimal. So moving on, here is the value chain from production, to the end user. So which is something we are very familiar with, especially those that uses commodity gas, like the hospital, they need oxygen, and so these are the simple value chain. So, but in the past, this comes from natural gas, steam method reforming to produce hydrogen. But now we can electrolyze water to produce hydrogen and oxygen. The oxygen can be used in the medical facilities, while the hydrogen can be used in generating electricity for other aspects of the industry, or maybe our energy production. And here are some of the facts. So we know we have the production, we have the transformation, we have the transport, we have the end use. So the end use cut across this, and these are the new standard that are on to provide opportunity for the industry. So I won't want to go too much in this. And in terms of color spectrum, what we used to do from our petroleum refining, from our steam metal reforming, is the gray hydrogen. So now the support system are there. The companies should, the refining companies should look into the adaptation of a carbon capture unit, to produce blue hydrogen. So when you have your carbon capture in your steam metal reforming, then you have blue hydrogen. You can get some carbon credits, you can get some incentives. At the same time, we can also look at pyrolysis, splitting the carbon from the hydrogen and having a kind of residue like carbon black, which can be used in the tire manufacturing or in the paint, ink, and all those kind of things. Then you have the electrolysis, which is the green hydrogen. So the pink is also nuclear. So if you have nuclear and you have some waste heat, you can use that waste heat to produce splitting process for uh, for water, and the color continue to emerge, So green hydrogen hubs and the hotspots are, hydrogen hubs are emerging. For example, I think there's something here in Namibia going on, and I think you see in different parts of the world. So Nigeria should also play a very fantastic key role. I know today, there was an event organized by one of the agencies in Nigeria, I think Energy Commission, about hydrogen. And I think this discussion is on sports, that it was like a 3-day capacity building workshop on low carbon hydrogen economy for ministries, departments, and agencies. So you can see, so this is something we've been discussing for more than 10 years. As far as Nigeria is concerned, we need to take this aspect serious in our national energy strategy. So already, uh, projects have been put in place. So there is a test for shipping of hydrogen from Australia to Japan. You can see. So this is for the green hydrogen, though the project was not so successful. So there were some test issues that came on board, for example, with leakage, the burning of hydrogen along the way, which they were not able to see the flame, and a lot of all those things. And those are test projects to demonstrate what is possible. So already there are a lot of agreements, international agreement that has been signed for the production of hydrogen from Australia to supply to Japan, South Korea, and to Singapore, and also from Saudi Arabia to South Korea to Japan, from UAE to South Korea and Japan, from Namibia so to South Korea, to Germany, and Nigeria needs to play a vital role to also have a production of green hydrogen or even blue hydrogen to places like Japan and other parts of Europe, and this should be looked into. So already these channels are already in place with all the agreements. So ammonia and methanol and the likes are also being looked into, especially when it comes to the green ammonia, green methanol, and the likes. And you can see different industry where they are being used. So power generation industry, shipping, chemical, fertilizer, ammonia cracking is also going to be a major part in ports. So where we have ammonia cracker being placed in ports. So, yeah, so coming to some of all these emerging areas, especially when it comes to many hydrogen hubs and valleys being put in place, especially in Europe, and I think some part of Japan, China. So, not only green hydrogen, also other forms of hydrogen, especially the gray hydrogen, is going to play a very key role. And if we're able to generate electricity from renewables, like we have the potential in northern parts of Nigeria, like solar, in the southern part we have hydro, and even in the middle belt we have hydro. So we could come to the concept of power to X, where we produce the electricity from renewables. It could be wind, it could be solar, it could be hydro, and convert it in terms of electrolysis to X. So the X could be electricity, it could be commodity chemical, it could be any form of product that we want to produce. And you can have several industry utilizing them. Like the cement industry is also utilizing this kind of system. And looking at Africa as a continent, so we are highly blessed. The renewables are there. So just look at West Africa, where we come from. You can see the amount of the potential for wind, for solar, you know, everything is there. So, and you can see north, south, every part of Africa. So a huge amount of solar, a lot of wind, hydro potential is also there. Geothermal is also there, especially in the eastern part of Africa. And the biomass is also huge for us in Nigeria. So this is just to give us an understanding. And here are some projects that are being initiated. As you can see, they are planned projects. So also some part of Nigeria. So as far as when it comes to where we can produce hydrogen, but a solid off takers needs to be put in place before many of these projects needs to kick off, especially who will be the users. Already locally using hydrogen has not been fashioned out, but for export commodity has been a major attraction. So these are some of this, and you can see the green hydrogen projects. So some of them are scattered everywhere. So, and as you can see, the potential of green hydrogen, which is possible for us in Africa compared to the rest of the world. So we are at a kind of crossroad where we have the potential, we have the labor, the workforce, the brain, we have the energy, but we need to put policies in place and all these necessary strategies. So some key projects already initiated. So none has been shown for Nigeria so far, but you talk about Namibia, South Africa, Egypt, Tunisia, Algeria, Morocco, Mauritania. So something needs to be done in Nigeria, and we need to be much more serious with our energy mix and play a key role as far as the global strategy is concerned. So the International Energy Agency also show us this chart that by 2030, in terms of planned hydrogen export by region, so Latin America will be a major key player, followed by Australia, as you can see from what I show you. So, but for Africa, so if you look at Africa, so we have Mauritania, Angola, Morocco, Namibia, South Africa, Egypt. So Nigeria has not been included. So I believe if Nigeria wants to be strategic and be serious with this, we can play very key role. So this can be up to in terms of comparison to even Australia and Latin America. So just to give us a kind of potential that we are missing out. So the emerging standard, as far as hydrogen is concerned, now you have the International Standard Organization coming up with a lot of guidance. My organization too, we are chunking out a lot of regulation, advisory, and a lot of approach to handling hydrogen. to handling methanol, to handling ammonia, because ammonia is very toxic itself, aside us being using it for maybe marine fuel and all those kind of things. So, and for safety, for certification. So at the end of the day, major regulatory drivers are the International Maritime Organization, the likes of also the International Organization of Standard, and all this European Union, and even here in the US, where you have the kind of a tax credit system so for this kind of things. So having all this in mind, we know the standard are evolving, and they will continue to evolve, and they will play a very critical role, because we know hydrogen will need to also be cost competitive in the coming years. There's infrastructural gap, which is a major challenge, and harmonization of the standard. And this is why the International Organization of Standard is putting all these other continental standards together. If you go to Japan, they are doing very well. Singapore, they are doing very well. In fact, Nigeria can also be a hub where we can produce hydrogen, convert this hydrogen to ammonia, methanol, and create a kind of hub within the West African uh, coast to create that kind of approach Singapore has. When it comes to marine fuel bunkering hub worldwide, Singapore is a major part. Nigeria can also make play key parts like that. So in Africa, and scaling up challenge is also there. But the new opportunities here are new green industry, new business opportunity, new businesses for companies, major players, both the national player and the international players, as well as the local practitioners or players, companies in Nigeria. So energy security will be there, job creation, and also will also contribute to global emission reduction. So at the end of the day, we've talked about how hydrogen is going to play a key role, and it's already playing that key role. So it's just that we are not seeing that, except for a lot of capacity building and strategy creation in Nigeria with different organizations. But most of all these things are being pushed by foreign organizations. And I'm looking forward to an in-house, in-country discussion where we can really have a real strategy for Nigeria. Except we just want to jump on the wagon that, oh, they are going to give a kind of a counterpart fund and everybody's happy. But how do we bring this into reality when it comes to our economic diversification and development and growth? So hydrogen enables decarbonization, where electrification is difficult. Hard to abate sector, that's a difficult to decarbonize sector will depend on hydrogen and its derivative like ammonia and methanol. And the robust environmental standards are essential for market confidence. And this is where NIE is going to play a very key role as a body representing the engineers in Nigeria. And hydrogen is very strategic and an enabler for net zero strategy. So at the end of the day, putting all this together, we know hydrogen is not simply an energy carrier alone, but it's an energy vector. It's also going to catalyze resilience, cleaner and sustainable global development. And also it's going to be a kind of uh, vector to help us see how we can also diversify into some other new businesses for our economy. So, and aside this, these are some of the points which I also want to address. And I believe if we're also looking at the net zero agenda, which is being powered by, I think, Ministry of Environment, as well as the Nigerian Climate, I've forgotten the name of this agency. So we need to start to play a much more serious role, not to be on lookout. We should be active uh, uh, enablers and influencers to ensure that we have a sustainable development for our dear nation. So I thank you for listening, and I'm happy to welcome your questions. Thank you.
Thank you so much, Dr. Ibrahim Kolawole Murtala, for your impactful and educative presentation to us. We are so grateful. We really gain from what you have lectured on us. So it's now the section for question and answer. Our distinguished engineers, you can ask questions from Dr. Inch Ibrahim for the presentation made now. Thank you. Question from our engineers or any suggestion on what he has presented. What can we add?
Good evening, all.
Good evening, sir.
Good evening,
Chairman.
sir.
I want to especially appreciate the presenter for really exposing for us this in thing about hydrogen. Honestly, I never knew hydrogen has such a potential for net zero emission, and that even it is even significant for Nigeria to meet its environmental standard. I want to first of all appreciate the presenter for really exposing us to this global trend, which is a clean fuel that can help decarbonize the hard to abate sectors such as the oil and gas. I have seen today that hydrogen matters globally. So having said that, I also want to get more clarification concerning this blue and green and even gray hydrogen. We are trying to grasp the fact that what hydrogen can do for us, and now I understand blue and green, and Nigeria has a huge gas reserve. So can you throw more light what specific environmental standard or regulation, first of all, to throw more light about the difference between the green and blue hydrogen, and then on the issue of gas flaring, what specific environmental standard or regulation will make it mandatory to convert this flared gas to hydrogen instead of paying penalties as we are doing currently in Nigeria? I hope
Yeah, thank you, sir.
my question is clear. Thank you.
Yes, thank you. Nigeria is known to be a gas reserve nation in terms of our potential for natural gas. And since hydrogen is going to help us decarbonize, one of the major products you can gain from natural gas aside electricity is hydrogen. So where you do your steam method reforming, which is your gray hydrogen, because you have emission. But if you're able to capture that emission, and that comes to the process angle where you can do some value chain addition. And this is why it's important for us as a nation to also create our own technology, because part of the challenge we have is we import, or a company is doing this somewhere, we bring it, we start using it, we are in trouble, we need to bring them, so we need to start to produce our technologies. Our universities need to chunk out a lot of all these solutions where we can encourage startups, engineering and procurement companies locally to fabricate, to design, to have those kind of solutions to be tested and used on our oil fields, on our gas field, on our gas plants, and the likes. So when you now move away from the gray hydrogen that we produce, especially refineries produce gray hydrogen, but there is emission. But if you're able to capture this emission using carbon capture solution, this hydrogen you produce from there is called blue hydrogen. And blue hydrogen has a premium value in the international markets. On the other side, if you don't use natural gas, you just use, let's say, any renewable source, maybe tidal waves to generate electricity, or hydro energy to generate electricity, or wind or solar. when you have this electricity, you can channel this electricity to an electrolyzer. And the purpose of an electrolyzer is to split water. And when you have hydrogen produced from this, that's green hydrogen. It has a premium value too. So, and this is what many global and international companies are looking for. So, but since we have natural gas, for me, I've been encouraging the players in this sector, especially in Nigeria, to look into how our gas can be uh, used. So for gas flaring, there are several solutions available for that. So, flaring itself is an operational effort, you know, when you don't have pipeline network, but you want to produce your oil, all those kind of things. So, or you don't have the infrastructure for the gas gathering system. So flaring is an operational aspect that is inevitable. On the other end, regulations that discourage flaring should be held tight, where companies going into business should be encouraged to utilize their gases instead of them flaring them. So, for example, you can channel what you have to go into your flare stack to a kind of modular system, like a simple gas to liquid technology, and create a kind of modular symmetry for me to produce syngas. And when you produce syngas, you can produce methanol. When you produce syngas, you can even have your hydrogen removed from your oxygen, and even your hydrogen removed from your carbon monoxide, where you have your hydrogen further being used with hair separation, where you have nitrogen to combine to produce ammonia. So, or if you still want to use that syngas, which is the combination of hydrogen and carbon monoxide, you can produce your methanol. And methanol also have a very high value worldwide. So all what we are saying are standards in many parts of the world. And these are shaping what we term the environmental standard. We have regulation for emission control from airline, from buses, from ship, and all those things. But now those alternatives are there, and they are being placed on the table for us. And it's our duty as a nation to also look into that if we really want to cut down our emission and say that, okay, we have alternative to all this fuel. And this is why you see the Dangote refinery is doing much to have high premium gasoline in order to have less emissions compared to what we used to have in the past. So at the end of the day, all these regulations are out there. As a nation, we just have to go back to the drawing board and look at what works well for us. Green hydrogen might not be the major business for us now because we need electrification first. Where you have excess electrification, you need to utilize it and channel it to electrolyzers. So this is why it's important to look into our national strategy and try to do some real work and alignment to ensure that we create business, we create job, we also create uh, opportunity for the environmental ecosystem. Thank you. I hope I'm able to answer your question, sir.
Okay, thank you. Thank you. I appreciate. I I appreciate from what you have said. We need electricity first to be able to produce this hydrogen in Nigeria. However, I thought that in our northern area where we have enough sun, I don't know if that could have helped us as well to
Yes.
power through solar. Yes.
Yes, if you go to North Africa, Tunisia, Morocco, Egypt, they have the huge solar farms. I don't mean solar PV. It's CSP, concentrated solar power systems, and you have a huge chunk of them in North Africa already. They are producing hydrogen. They are producing all these kind of products I may mention through some kind of processes and CSP in Tunisia. So let me just, I think I should have something just to show you. So just for you to see this kind of, and all these desert that you call deserts are now resource spots. So let me just show you this. So, I mean, we had a project in 2012, which we completed in German aerospace and already, so just for you to see. So this is a CSP plant, so continuous solar system. So here you have the receiver. So I mean, this is another set of technology. So where you can produce, you can use this to split water. So the water comes from, I mean, some kind of wells around, and they split water to produce hydrogen. You can also use this to generate steam itself, where you can also use it to generate another set of electricity. So already all this kind of technology are already there. So we don't have this in Nigeria, and I think some universities are already, I mean, we are in discussion to like do some demonstration to test some of this. So, but this exists in many parts of North Africa, and all this technology originated from Germany. So they are the first to develop this kind of technology, and it's being used, and that's why it's called concentrated solar power technology. So yeah, and this is why I said we need to go back to develop a kind of national, rework our national strategy, where we look at what different regions have. Just for example, look at the southern part of Nigeria, especially the Niger Delta. We still feel oil and gas is the main thing. We've not even utilized the hydro potential from the Atlantic Ocean. We've not used the wave. We've not used, we've not used those ones for wind energy. We've not used it for tidal waves. We've not used it for, we've not even used those kind of. You go to the Lagos Bar Beach, you just see those wave. Those are energy generation spots for us, and it's all about national strategy where we can adapt some of all this technology and start to localize them. We generate maybe like 1 megawatt, we supply to nearby recreation centers around that place. You go to the middle belt, you have the River Niger, you have the River Benue, you also look at the potential, you have the Geregu, all those kind of, I mean, even some dams, that we have, and even some villages, they still have potential for moving a river, the water body is also moving, which we can produce hydro energy. So, and this is why I'm happy that this current government really push for a kind of state kind of state can generate the electricity. So it's until when we are very serious to start to produce energy locally, I think we can start to see how we can further expand to create more value for that, because electricity is not only about us supplying to homes to use for lighting and even for cooling. No, there's a lot of things we can do with that. I hope I've answered you, sir.
So, thank you.
Anybody with any other
Yeah, I think
answer,
we have
any
one hands up.
questions or okay. That
Hello,
person
sir.
can go ahead.
Yeah. A very good evening to everyone on the platform. I want to thank Prof for this insightful presentation. Honestly, we didn't expect anything less than this. I mean, we've seen um, a lot of your works in the past, and of course, your contribution to NIE at the state and the national level as a former National ESCO member. Thank you very much. But yes, when it comes to energy, there is need for an energy mix everywhere in the world. So we can't. There's no need for energy mix. People, of course, send towards these hydrogen gas we're talking about today. But for Nigeria, trying to kill is a major challenge. Now we have Sorry, I have to mention name. We have the Dangote refinery. So how do we ensure that we are able to apply some of this technology? I know the steam methane reforming is key to actually breaking down hydrogen gas using the Berkeley reaction. But then, how well do we incentivize this um, upstream and downstream? um,
Okay. I hope I'm able to hear Engineer Yusuf. Maybe it's from my hand, or is it a general challenge? Hello,
Okay.
hope I'm audible.
So sorry, I lost my
It's general
network.
problem.
Okay. So what we're trying to say is that for the likes of Dangote refinery, how can we ensure that they extend some of their processes towards you know carbon capture and sequestration, and also trying to generate hydrogen gas? Is it that it is not cost effective for them, or they choose not to do it? What can Nigeria do? What can NIE do as an institution to make sure that all of these organizations begin to adopt this kind of technology that is going, I mean, very viral? I know at some point in time, yeah, I know we had this kind of discussion that, I mean, I wanted to even really go into PhD on this kind of area, as far back as 2009. But in Nigeria, still not keen in appropriate like you presented. So what can NIE do to accelerate this? Thank you.
Okay, thank you for this. And I'm happy you made mention of what NIE can do. NIE can do a lot. And I've seen a lot of movement and all these meetings in Abuja. I read it. I mean, a lot of news, just such different news outlets in Nigeria. You see a lot of meetings being held, and I've not seen NIE in most of all those meetings, and I don't know why. So you'll see NSC sometimes, Nigerian Society of Engineers do participate sometimes, but NIE, even this climate, something, I've forgotten the name of the body. So I hardly see NIE in all this meeting, and I think it's important NIE needs to be well represented. Even this 3-day workshop that took place that is ending today, I mean, I think it's just ended today. When I saw it, I look at all the organizers. So they said they want ministries, agencies, and I think NIE should be on board to be part of the 3-day workshop where we have representative to give talk, to give lectures, even to train. So I believe NIE can really work with several of these platforms, starting from the Ministry of Energy, Ministry of Environment, and even down to several agencies to provide capacity building, to provide awareness, to provide business case studies, to provide demonstration and model project in partnership with our universities. So where we say, okay, we want to look at some key possibility for regional programs. So let's say the Northeast, Northwest, now, the way we have that formula of regional program, I mean, sharing, and look at one pilot project per each region and use this as a kind of case studies to demonstrate the potential and possibility. So we need to look at that. So, and these are some of the things NIE needs to do. And there are many more things that I feel NIE can look into. Then, as a nation, like I said, we need to be much more serious with all this. Gone are the days that people will go for the COP programs and go for merrymaking and jamborees. Most times, even sometimes, whenever I even go for some of those conferences, whenever I go to the Nigerian section, it's more like jamborees, not serious activities. So we should be more serious to go and strike deals, sign partnership, where we sign partnership for technology transfer, we sign partnership for capacity building, we sign partnership for exchange programs, There's nothing stopping NIE team to visit Germany or Norway. Wow. So there's nothing stopping NIE to visit some of all these advanced nations for business visits, for case studies and knowledge sharing. Japan, Singapore, and the likes, and put together some paperwork in terms of policy to be discussed with the National Assembly, even at state level, at national level. So these are some of the things NIE can do, and these are some of the things we should promote. Then, in terms of, uh, I also feel our young professionals needs to be mentored and encouraged, and it's also part of what I kind of advocate for in many of all these platforms. Either we like it or not, we need to take this back to some of the universities where we come from and those ones we are affiliated with to start to nurture the younger ones to also participate in this kind of events we are having, you know, 1 day events, 2 day events, or quarterly base with them to educate them, to encourage them, because they are the ones that will fill up the workspace. And if they don't have all this awareness, how do we want to support the next generation? And for the organization like Dangote, I think he has been doing well with a lot of his business strategy. And, Nigeria, we had a kind of rescue mission with Dangote, and I think it's a very good one for us as a nation. Um, though we had the one zone by the nation, which is not working up to the right capacity that is required. And he came on board to have his own investment, which is a very fantastic and great effort. So I know he too will be looking into this, and possibly NIE can also reach out to him to also inform me about some of all this. I know he has a consultant that will be telling him about this, and that's why you see him also going into power. That he said he wants to join power because he knows the gas is there. So, and by the time he is able to do the power generation, the next thing he will start to think of is, oh, I have a excess energy to sell. Instead of me wasting it, why not produce hydrogen, green hydrogen, and also improve the value and get the premium from many of the countries outside. So I think he's strategically positioned to perform those wonders he has been doing, and uh, we as a body needs to see how we can further engage organizations like that. Not only the Dangote refinery, we also have a lot of companies coming up with modular refineries, you know, LNG companies, we can approach them and see how they can add value. Not only we produce oil, we produce gas, we sell or we refine. There are other areas that we need to touch. Many of them too are also looking into starting new business segments like Wando. I think they already have their renewable segments, renewable energy segments. So these are some other added value chain for them, which many can look into. So I believe uh, we as a body needs to be able to put facts together for them. Thank you.
Thank you, Doctor. Thank you. We are so grateful for your presentations. Do you have any other questions before we move on to the next agenda? Distinguished engineers, do you have any other questions we want to ask our guest lecturer?
Good evening.
Please, your name.
My name is calling from, please. Mustafa Muhammad Kabir.
Welcome, sir.
Thank you very much. Yeah. Can I proceed?
Go ahead.
Okay. Okay, thank you very much, and thank you very much, Prof, for this wonderful presentation. It's such a great opportunity to be here. Actually, I'm a student of I'm a master's student of Sustainable Environmental Studies, and I can say that this is a great opportunity for me because I am trying to pursue a project research in decarbonization. I work with in a cement plant where I can say that some of our operations used to produce carbon peroxide released into the atmosphere, and I believe this is having a negative effect on the environment. So I want to know if we can, if it is possible for us to employ the use of this hydrogen gas in kiln firing, so that we can be able to reduce the CO2 release into the environment and the possible hydrogen gas sources here in Nigeria.
Yeah, thank you, Mustafa. And this your company is what do you produce? Cement or what?
Yes, sir,
Okay,
yes, sir.
good. So for decarbonization strategy for cement industry, the first thing is what we kind of do is to look at your processes. What kind of
Okay.
energy do you use?
Yeah,
Part of the benefit which many cement industry don't see is that they
yeah,
they they puff out a lot of CO2 emission. And this
yeah,
CO2 itself is a major resource,
yeah,
you know. So, and I know part of what you consider as your cleaning process is to have a kind of filter system to
mm,
reduce dust, dust and particles emission, So, but there are
yeah,
other aspects, and the cement decarbonization has its own strategy. Hydrogen
yeah,
could come into decarbonization for cement when you now
yeah,
want to also have that premium cement called green cement.
yeah,
The major player in the world is Cemex, that cement company. I think it comes from the company comes from France or somewhere. They've been able
yeah,
to demonstrate this, so and I was also involved in
yeah,
the whole experimentation process to develop the technology for them. So
yeah,
where they can be able to adapt instead of using Western energy in their calcination unit. Your calcination unit is a major point where you need energy.
yeah,
Where you mix the different kind of particles, the
yes,
limestone, and that
yes,
calcination unit. So
yes,
you need to
yeah,
do that energy balance around it, and
yeah,
yeah. So and from there you'll be able to see where you can adapt to that. By
yeah,
the way,
yeah,
the concept of power to X can be integrated into cement. And I think this has been well recommended to companies like Wando in Nigeria, but many are not looking to this, Lafarge and the likes too. So we've had a lot of discussion on this, but many are not looking at this. And this is where we need to reorientate ourselves as a nation. If you look at many industrial countries, they have something called industrial hub or
yeah,
industrial park, those kind of things, platforms or let's say place.
yeah,
What you
yeah,
produce, the cement you produce, you should be able to have a company closer to you. Let's say a glass manufacturing company, or maybe an
yeah,
aluminum production company, or maybe a steel company. So that
yeah,
means the waste heat from you can be supplied to the other company to produce some of their products. Or it
yeah,
could be a kind of concrete or maybe tiles or ceramic or all this kind of toilet WC system things, manufacturing companies. So at the end of the day, what this gives us the opportunity to integrate, to be able to reduce waste, to create more value for what used to be our own waste. So, and with that, even the CO2 that you have, we can further crack down CO2 to carbon monoxide. And if we have solar potential or wind potential, we have hydrogen, then we can produce more products, chemicals, you know, and all those kind of things. So there's a lot of kind of reorientation that we need to do, and we call this term sector coupling. So where you can couple different sectors together and be able to generate more value and there will be more productivity. So these are some of the kind of national orientation which I feel we need industrially. And uh, this will take some time, and I believe many of the players here are also listening and we can further see how to expand on this. Thank you.
mhm, yeah. Thank you very much, Prof. Thank you very much. I appreciate.
Thank you. Thank you. We can now move to the next.
We have Engineer Ibrahim's hand on.
Okay, Engineer Ibrahim, you can go ahead. Because time is not our
Good
friend.
evening, everyone. Pardon the noise. I'm in transit. Bro, it's
Okay.
good to hear your voice, sir. As you and I both know, working on this thing for some years, how can we pass this knowledge and bring to students? Thereby, they do their projects, maybe from BSc level, MSc level, PhD level. If they can have that knowledge, because one of the biggest issues we have, I think, is the in the case of fuel cell, but don't let's go to the discussion. So how can we pass this knowledge to them? Because it's not just in school these days. It's taught primary and small. How can we, as NIE, how can you assist us to get back across to them? Thank you, sir.
Okay, thank you so much for this wonderful question. And I think I'm also an advocate for knowledge transfer, skill acquisition, and the likes. I think the first thing we need to do as a body, and this is where maybe the national leadership of NIE needs to look into this. We have affiliated chapters maybe from universities and polytechnics. Possibly maybe on annually, we can always promote, maybe we create a platform where we promote uh, projects that has to do with those environmental engineering or science related that need to be scaled up. So where we create a kind of challenge where we have students come to pitch some of their final after they've defend their final project, maybe at PhD level or even masters or even bachelor's or undergraduate level or maybe ND level. Because most of all these projects that many of our students do, um, they are very important for national development. But we don't take them serious because we feel it's just a project to pass and graduate. And this is where bodies like us need to do more to be closer to some of this university. Maybe we have a license officer that is in charge of students and the NIE relation program to create a platform for them to promote, present, and also project their new ideas. And from there, possibly we can even create a kind of international funding session where people that have this money wants to invest in those kind of ideas and also to help them scale it up, maybe to go to some lab in Abu Dhabi or in Japan to do some tests. And so these are some of the things we need to do. And this is where NIE also needs to partner with maybe the Petroleum Trust Fund, PTDF, or where you can development funds to partner to do some of this kind of thing. Because I know many people are being sent abroad on scholarship, and some go, some don't come back, and it's a loss to the nation. And this is where we need to do more as a body to see how we can um, facilitate this kind of platform for knowledge development and generation of new ideas for industrial implementation. Because all what we are seeing are all industrially applicable everywhere. We talked about marine, construction, building, aviation, refining, cement, petrochemical, refining. So we need to create that opportunity. So I know in the past we usually organize this uh, uh, World Earth Day where we have a student from secondary schools where they present a kind of essay. I think it's a very good one. We need to encourage more of that at university level or maybe our institution level. So these are the ways I feel we can further promote and enhance knowledge transfer and skill development for our younger one. And also the older ones, who can learn from them and also guide them and mentor them to see how their ideas can get to the right players, because many in advanced world, sorry to add this, you see companies like Siemens, they have an open day, they have a kind of innovation session or hackathon or whatever kind of session where they expect students to come over to pitch some of their best ideas. Companies like Bosch, many of them, we all know them. Even the likes of Chevron, Exxon, they do all this in many parts of the world. Shell. So we need to see how we can talk to some of all these major players and see how they can enhance some of this together with some of our agencies and uh, stakeholders. Thank you.
Thank you. Thank you, our guest. We really appreciate all your impactful, educative guides and lectures. May we now move on to the next program on the agenda, because time is fast moving out for us. So we now move on to the information from the Secretariat that will be given to us by our National General Secretary, Engineer Yusuf Majolagbe, FNIE, FNSC, PMP. Thank you. The mic over to you, sir, our National General Secretary.
Okay. Thank you very much, my National Technical Secretary, and of course, our National Chairman and our entire members, fellows on this platform today. Thank you very, very much. I know we've actually learned a lot, but today we just want to give us some information that are necessary for us to work on and ensure that we are a part of NIE. So number one on the call is that our membership portal, our online portal is very, very much active. So for new members that are interested in joining, you can just go online and do your registration. You can equally make your payment as well. For those that are already members, you can update your profile on the online portal and as well make the payment for your annual due. So just go to www.niee.org.ng/portal and you will be right on board. The other information that we have is that NIE is commencing its continuous professional development program, that is the CPD program on the 1st of July. And this CPD program is responsible for planning and executing this committee. There will be a committee that will be set up that will be responsible for planning, executing trainings, seminars, and workshops that ensure that NIE members meet the NIE, NSC, and COREN mandatory CPD requirements while staying current in environmental engineering practices. We also have some international tour, which I believe from what Dr. Ibrahim has mentioned today, we hope that we will be able to connect with more people like Dr. Ibrahim in diaspora to advance the course of environmental engineering in Nigeria. So there is a particular trip in August. And this is in collaboration. NI is in collaboration with NICE, that's Nigerian Institution of Civil Engineers, as well as the NSC Manchester and Glasgow branch. There will be a UK engineering conference coming up on between the 6th and the 8th of August, which will also be a part of. And the initial visit will start with some industrial tour at Manchester coordinated by the NSC Manchester branch. We would also be having um, another international trip with NSC Calgary to Europe, and that will be between the 2nd and the 13th of November 2026. And this will be visits to Spain, Poland, Switzerland, and Italy. So we will actually have to select two of these countries. So some of the local programs that we have is the Father Unsi Memorial Lecture, and this is tentatively to hold on the 22nd of August 2026. The venue will be at the Engineer G.O. Awerioba Engineering Center, 184 Ekenwa Road, Benin City in Edo State. And lastly is that we are also working towards planning for the national conference and annual general meeting of the NIEE, as well as the fellowship dinner slated for just the weekend before the NSC conference. That should fall within the last weekend in November, and the venue will be at Abuja. So we should also, as engineers, be willing to attend the NSC conference. The NSC conference at Maiduguri, that's by the end of the year. So once it is confirmed that the next National ESCO meeting and our chairman notifies us, then that means we all need to start preparing to attend that conference, and as well, stop by at Abuja for our own national conference before heading towards Maiduguri. So that's the information we have for us from NIE. So thank you very much. I'll drop the link for registration on the chat box so we can also pick it from there, and is also available on our social media handles as well as on all our WhatsApp platforms. Thank you.
Thank you, sir, our National General Secretary, for the valued information given to us. Before I move on, may I call on the National Chairman, sir, if you have anything for us, because we are rounding up. If you have anything to tell us, to tell the House, to guide us on, or anything you have, sir. Over to you, sir, the National Chairman.
Thank you, sir. I would not like to add to all that. I think I only want to thank the presenter and the technical team for putting together this. I also want to appreciate our student members who have joined us. This is the essence of your affiliation with us. We look forward to more students joining us in our subsequent webinars that will be coming up. And I want to let you know that from month of August, webinars like this will begin to earn you points that will be useful for your accreditation and for other incentive that you are going to gain in this, being a member of this. Going forward, our webinar will have points. It is in line with the CPD mandate we are trying to establish by next month. So do well to join and tell others about NIEE webinar. I believe everybody here have learned a lot. Me, I have learned, and I know our students' mind has been activated to think towards this line. Thank you, our presenter. It was a wonderful time with you. Thank you.
Thank you, Chairman, sir. We're grateful, sir. So the next on the agenda is the e-certificate, which will be handled by the Secretariat, but that will be later after this program. The case is the presenter later. So for now, we're rounding up today's webinar and technical sections. I would like the Assistant National General Secretary, Amiable Engineer Benjamin Amali Kolo, FNSC, FNIEE, to give us a closing remark. and vote of thanks. Engineer Benjamin, are you there, sir? Vote of thanks. Engineer Benjamin Amalikolo, sir, are you there?
Sorry, because we have another meeting, right, which they are calling me now. So I'm there. Good evening.
Good evening, sir.
Hello.
Hello, we can hear you, sir. We can hear you, sir. We can hear you. Go ahead, sir.
Okay. All right. Good evening, everyone. Good evening, the chairman of NIE. Good evening, distinguished members of Nigerian Institute of Environmental Engineers. And good evening, the presenter, engineer, Dr. Eng Ibrahim Kolawole Muritala, fellow of Nigerian Institute of Environmental Engineer and fellow Nigerian Society of Chemical Engineer. I want to appreciate everyone for making our time to be part of this technical session today. Thank you for your time. Thank you for listening. And I want to especially appreciate the presenter for a insightful lecture. We thank you for the time it took you to put this lecture together and to make the presentation today. Of course, you have enriched our knowledge, and we are praying that God will continue to increase your knowledge more and more.
Yeah.
So I'm appreciating everybody for the time to be in this meeting. And as we go, a lot of us were on transit as the session was going on. I know that God will take every one of us back home. Those that are on transit will get home safely. So I thank everyone. You are welcome. And may God bless everyone.
Thank you, sir. We are grateful.
Thank you, sir.
Yes.
Thank you all the listeners for coming. We have come to the end of this webinar.
Thank you, sir.
Technical section. We are so grateful for your participation. May God bless all of us. Thank you.
Thank you.